Hi, I am Arib. You are watching my YouTube channel. What's the difference between transmission and distribution power lines? Definition: utility companies use two different types of power lines: transmission and distribution power lines for the transportation of electricity. While transmission and distribution lines work together to carry and deliver electricity from power sources to consumers via the energy grid, they serve different functions, and there are a number of key differences between transmission and distribution power lines. Difference between transmission and distribution power lines. The core difference between transmission and distribution power lines is that transmission power lines are for long-distance, high-voltage electricity transportation, whereas distribution power lines are for shorter distances and lower-voltage electricity transportation. To illustrate, transmission lines are the power lines you might see on the side of the freeway, while distribution lines can be seen on the sides of streets. Transmission power lines. Transmission power lines carry bulk electricity from the generating power station to a number of substations. Key functions and features of transmission power lines include: key features: voltage levels 132 kV, 220 kV, 400 kV, 500 kV or higher. Distance: long range, hundreds of kilometers. Objective: reduce power loss, maintain stability, handle bulk power. Types: primarily overhead lines, sometimes underground cables. Major components: step-up transformers raise voltage from generator output for transmission lines, high voltage conductors, AC or HVDC, substations, grid stations, switching, voltage regulation and protection, switchgear protection systems, circuit breakers, relays, and monitoring devices. Types of transmission. There are two types of transmission lines. AC transmission, HVAC, most common, flexible. DC transmission, HVDC, efficient for very long distances and submarine cables. Advantages: low transmission losses due to high voltage, ability to transfer bulk power over long distances, integration of multiple power sources in a grid. Disadvantages: high initial infrastructure cost, complex maintenance and protection systems. Distribution power lines. Distribution power lines carry electricity from the substations to the consumers, completing the electricity journey. Key functions and features of distribution power lines include: key features: primary voltage 11 kV, 33 kV, secondary voltage 400 kV, 230 kV. Distance: short range, within cities, towns. Focus: safe, reliable delivery to consumers. Major components. Distribution transformers step down voltage for end users. Feeders carry power from substations to local networks. Distributors service lines supply electricity to homes, industries, and commercial buildings. Meters measure consumption. Types of distribution networks. There are three types of distribution lines. Radial system, single path, simple and low cost, low reliability. Ring main system, closed loop, moderate reliability. Interconnected system, multiple sources, high reliability. Advantages: easy to maintain locally, can be adapted for future load expansion, direct control over end-user supply. Disadvantages: higher losses compared to transmission due to lower voltage, vulnerable to outages in radial systems. Transmission substation: step down from high voltage to primary distribution voltage, includes switchgear and protection devices. Distribution substation: supplies multiple feeders, steps down to 11 kV or lower, provides metering protection. Transmission losses: conductor, copper, losses, I square to R, corona losses, ionization of air around high voltage lines, dielectric losses, insulation losses. Distribution losses: technical losses, I square to R in conductors, transformer losses. Non-technical losses, theft, metering errors. Protection systems: transmission protection, distance protection relays, differential protection, overcurrent and earth fault protection. Distribution protection: fuses and circuit breakers, reclosers, overcurrent and short circuit relays. Conclusion: transmission system focused on efficiency, high voltage, long distance. Distribution system focused on safety, consumer supply, low voltage. Both are interdependent for a functional power network. Understanding both systems is critical for power engineers, technicians, and planners.